What's happening, everyone? Today's lesson is on section 13.4 and it's something called definite integrals. Now this is a huge use of integration. We've already looked previously at integration as the reverse of differentiation. So if I know what the differential of some equation was, I can reverse that using integration to figure out what the original function was. Okay. Now that has quite a lot of implications when we start to look at it applying to mechanics, and I know some of the further maths students might have seen this already, where we can reverse a formula for acceleration to figure out then what the velocity formula was, and backwards to figure out what the distance formula was. However, in pure maths, that doesn't come up an awful lot. This is really important because, I mean, you can skip onto the next page if you want to and have a little look, but basically this allows us to figure out something really important to do with maths and to do with graphs, and it has a huge implication for things moving on into further maths and degree level study and stuff like that, which I could show you if we were all together, but I'm not going to try and sort of fiddle around with everything on the computer at the minute. So the difference this time is when you have an indefinite integral, you end up doing the integral of some sort of function dx, and when you get your answer there, you'll write your answer with a plus c at the end. Okay, that is when it is indefinite. That is when you do indefinite integration. Indefinite integration, that's your plus c. Definite integration looks like this. It will have numbers there and there that it wants you to use, and I'll show you what to do with them, but you don't write c. You don't put the plus c for definite integration. We do something and we get an actual number as our answer. Okay, the number, you'll see what it is. It's something to do with areas underneath curves, which you'll see later on, but that's what we do. Okay, now the process here is effectively you integrate exactly the same way. Okay, you just don't write that plus c at the end of it. What you then do is take that number, sub it into your answer, take that number, sub it into your answer, and then take them away. And that gives you a definite integral. Okay, so it's gone through an example there, integrated 3x squared to get x cubed, increase the power by 1 divided by the new power. The 2 and the 1 are there and there, subbed in 2, subbed in 1, take away your answer, and that's what they're left with there. Okay, so the process for this is you integrate, sub in your numbers, take away, that's your answer. Integrate, sub in, and subtract. Okay, so let's have a look at example 7. Evaluate this. Okay, so the first thing that we're going to do, step 1, is we just integrate. Okay, so we're going to integrate x to the power of a third minus 1, increase the power by 1, and I'm just going to keep doing all these on my calculator because a few of you are still getting a couple of these bits and bobs wrong. Don't try and do this without a calculator if you struggle with your fractions. Okay, so our power starts at a third. We're going to add 1 to the power. That gives me 4 over 3. So I know I'm going to get x to the power 4 over 3. And then I want to divide by that power. Now, if you struggle with that, remember dividing by 4 over 3, one way of thinking about it, you might have heard of KFC, keep flipping, change, whatever it was. Dividing by 4 over 3 is the same as times by 3 over 4. If you are stuck with that, remember there's a 1 there, so you are doing 1 divided by that new power, 4 over 3, which gives me 3 over 4. That's going to give me 3/4 x to the power 4 over 3 minus 1, which is minus x. Okay, now a lot of the stuff in this example, as you work through it, you might notice that, you know, what's going on with these brackets, why are those brackets there? Basically what we do is we write the answer to the integration in square brackets and put the limits there and there now. So we put the limits there. Okay, that's basically just to say the square bracket basically means that we have integrated it. We're now going to sub in. When we sub in, we put it in normal brackets. So 3/4, 1 to the power 4 over 3, minus 1. Take away, brackets again, 3/4, 0 to the power 4 over 3, minus 0. Okay, so that's what's happened there. You've subbed in your 1 there and there, and you've subbed in your 0 there and there. Okay, and those things have been subbed into this. Okay, so step 1, you integrate. Step 2, sub in your limits. And step 3 is effectively just solve and subtract. So figure this thing out, figure this thing out. Okay, so let's figure out this bracket, figure out that bracket, and then we'll write our answer over here. So 1 to the power 4 over 3 is just 1. Whatever, so that's 3/4 minus 1, which is minus 1/4. Again, do that on your calculator if you need to. 3/4 times 1 to the power 4 over 3, just 3/4. Take away 1 is minus 1/4. Minus 0 times anything is just going to give me 0, isn't it? Take away 0, so that's 0. So my answer there is minus 1/4. Okay? So integrate, sub in your limits, solve and subtract. Okay? Integrate, write your answer in square brackets. Write the 2 limits there and there. Sub in that limit there, sub in that limit there. And then just basically, once you've got to this stage, you could, if you wanted to, just plug all of that line into your calculator. It will get you straight to there. Okay? So that's how you do the normal definite integration. So we turn over and have a little look at example 8. Now this time, this is kind of working backwards almost. Given that p is a constant and that the definite integral of 2px plus 7 equals 4p squared, show that there are 2 possible values for p and find these values. So what this means is we're going to do exactly the same thing. It just means that we're going to get p's in our answer that we're going to solve at the end. Okay, so start exactly the same way. Let's integrate. So we're going to integrate between 5 and 1, 2px plus 7 dx. We're going to leave that thing for the time being. Okay, so if I integrate this, because p is a constant, we're going to increase the power, so that x will go to x squared, and then we're going to divide by the new power. So 2p divided by 2 will just leave me with 1p, and that 7 will go to 7x. Now because I've integrated it, just as a bit of notation, we just write that in square brackets and put 5 there and 1 there again, just the same limits there and there. Okay, so now sub in your limits. So we're going to get p times 5 squared plus 7 times 5 minus p times 1 squared plus 7 times 1. And we know that this is going to equal 4p squared. So we can see straight away there, yeah, that there's a little bit of kind of working out and stuff like Mr. Bracket there, haven't I? But that's going to give us an equation, isn't it, with p's in. Okay, so let's figure all this out in these brackets first. So the first bracket, p times 5 squared is going to give me 25p, plus 7 times 5 is going to give me 35. Minus p times 1 squared is just p, plus 7 equals 4p squared. Okay. Now, when you get to this stage, be very, very careful to always multiply this bracket out. 25p plus 35. What I'm talking about here is that's effectively a minus 1. That's going to give me minus p minus plus 7, which is minus 7, equals 4p squared. Okay, so that number there, you need to look out when you do that to make sure that this thing is taken into account when you expand that second bracket. Okay, so now what we can do is get everything over onto the right hand side, because that's where we've got a positive p squared. So 4p squared, 25p minus p will equal 24p, so that's going to be minus 24p on this side. 35 minus 7, it's going to give me 28 on that side, so that's going to give me minus 28 over there. And then we can just solve this, okay? And I'm going to use my calculator for that. If you wanted to do like divide all that by 4, you can do and solve it. I'm lazy, so I'm just going to plug this straight into my calculator. 4p squared minus 24p minus 28. See what we get. We get one answer is 7, and we get another answer is minus 1. Okay. So your definite integral method is exactly the same there, isn't it? It's integrate, write it in square brackets, sub in your limits, so you put on your 5 into there and there. Let's just show you what's going on there. Your 5s are there, and your 1s end up going there. When you multiply all that out, you get an equation in P, and basically all it wants you to do is solve that equation then. Okay, whereas on the previous one, at this step, it just equals your answer. But because we've got this letter involved there, that P, it means that this time we don't get our answer here. We end up having to set up an equation from that point on and figure out the answers that way. Okay, so what I'd like you to do, please, this is a really important topic, this, so genuinely, if there are any problems with any of this, please get in touch. It's really important. Okay, I'd like you to have a go at these questions 2, A and B, 3A, 4, 5 and 7, please. Okay, as I say, any problems, just let me know. And remember, all the stuff from before still applies. So this, you're going to write that as 2x to the minus 3 plus 3x. This one, simplify that. So you're going to do x cubed divided by x, which will give you x squared. 2x squared divided by x, which will give you 2x. So that's what you're going to integrate there. So make sure, remember this one as well, that's going to be 6x to the half. So all those things that you've already done really, really well with your integration, don't forget those things, please, as well. Okay? Right, good luck, and let me know if there's any problems.